Welcome back. In this special request series, I'm going to solve this question. The question is on gamma function. The first question asks us to define a gamma function. So the second question asks us to show one of the recurrence formula, that is gamma n plus 1 is equal to n gamma n. So, and the last one asks us to evaluate that integral. So that is not difficult to do. Number one, if you want to define a gamma function, gamma of a function n denoted by this. So it is nothing but integral from 0 to infinity e raised power minus x raised power n minus 1 dx. So integral from 0 to infinity e raised power minus x raised power n minus 1 dx. So if that is cleared, so from this one I can actually show the recurrence formula. Recall that we asked to show that n gamma n plus 1 is equal to n gamma n. That is not difficult to do. Recall from the definition of gamma n, you have it to be integral from 0 to infinity, blah blah blah. So it means when you want to find your gamma n plus 1, it means you have to substitute the value of what? N here to be n plus 1. So that is wherever you see n here, you substitute the value of n plus 1 there. And I'm going to have integral from 0 to infinity e raised power minus x. Now my n will be what? N plus 1 minus 1. Yes. What you observe, this guy will cancel this. Then you have your gamma n plus 1 is equal to integral from 0 to infinity e raised power minus s raised power n dx. So can you see this one? So you can see that you cannot use your standard integral. I have said in the previous video, you cannot use one of the standard integral. In fact, when you differentiate, the first function is not going to give you the second one. So then you cannot use integral of the form f of x multiplied by f prime of x. So if you cannot do that, then you have to resort to what is known as what? Integration by part. And don't forget, in integration by part, you make a function to be u, you make another one to be dv. When you make to be your u, you are going to differentiate, like I've explained, to half u. Likewise, the one you take for dv, you are going to integrate it to half v. And don't forget the priority order I gave to you, that is, if you want to take your u, you have to consider whether in your integrand, whether you have a logarithmic function ln x. If it is not there, you check for s raised power something. If it is not there, you check for e raised power something. So based on this priority order, it means my u is going to be what? That's s raised power n. Recall, you are going to differentiate it to get the u, and your derivative of u here will be what? Nx n minus 1 dx. That is, you differentiate this guy multiplied by this minus 1. So that is the exponent, will give you the new exponent. Likewise, your dv automatically is going to be e raised power minus s. Then your v is going to be minus x. So if that is cleared, then you now substitute into integration by part formula. Recall that integration by part formula is uv minus integral v du. That is when you want to integrate u dv. So then you are going to have uv minus integral v du. My u here is s raised power n. Your v is what? Is minus x. Is that taken? Then you put integral from 0 to infinity. I hope that is understood. No, so this will be e raised power minus x minus e raised power minus s. Yeah, minus e raised power minus x. So then minus integral, your v is what? Minus e raised power minus s, then du nx n minus 1 dx. Don't forget your limit. So if you take the limit of this guy, since we are integrating with respect to x, that is when you see, integral, when you see infinity, if you substitute it to be the value of x, infinity is a very big number. So Then when you take, its power, you understand now you are going to have, a bigger number as well. Likewise, e raised power what? E raised power minus eight will be a very big number, then it's going to approach what? It's going to approach zero. In essence, as n approach infinity, then you are going to have this to be zero. That's why I have zero here. Then this guy, likewise minus, when you put zero to be the value of s, zero raised by n is going to give you zero. Then this is going to be zero. Then recall, whenever you want to integrate with respect to a particular variable, you carry out the constant. This guy minus n is a constant. If you put it out, that's going to give you plus n, integral from 0 to infinity, e raised by minus x, s raised by minus, s raised by n minus 1. Yes, if you check it very well, so you will see that it looks like what I have on the top, at the top, sorry. So that is the gamma what? The definition of gamma n. You understand now? Then you can conclude adequately. You know what we are doing before is what? We are finding the value of gamma n plus 1. We are finding the value of gamma n plus 1. Then you can now say that your gamma n plus 1 is equal to n integral from 0 to infinity raised by minus s minus 1 ds. And don't forget my definition of gamma n, I said it is the same thing as integral from 0 to infinity e raised by minus s n minus 1 ds. So therefore, this guy will be gamma n. You are going to have n gamma n. So, and that's the proof. So the last one, you are asked to solve this guy, integral from 0 to infinity s raised by 1 over 4 e raised by minus 1 over 2 ds. So although if you check this guy, you can, this question very well, you can actually use your integration by parts. But if I were you, you don't need to use your integration by parts. You can actually use what? Your gamma function definition directly. Recall that when you have your gamma n, it is the same thing as this. You understand now? And there is one, recurrence formula or a formula in gamma that says when you have your gamma n, it is actually the same thing as what? N minus 1 factorial. I'm not going to prove that in this video because of the time. So you have to note this formula as well. So then if I'm able to transform this, to have like the definition of gamma, so then if I can obtain my n, then I can use this formula to actually find the gamma of n. So if you look at this very well, by transforming, let me transform this by transformation, sorry. By transformation, recall here that my s, what I must have at the power of this must actually be equal to what I have here. That is what you have here. You understand now? What you have here must actually be equal to what? So must actually be equal to what you are going to have here. You understand now? So okay, now let us proceed. If you want to transform, I can say this integral from 0 to infinity, the same thing as s raised power half everything raised power 2. Is that not so? No, I think the question is something is missing here. This is s raised power half minus s raised power half. So yeah. Then likewise, this is also the same thing as minus s raised power half minus s raised power half. Can you see? Let's check what you have here. That is minus s. Your s here. You have minus here. The minus is also here. Then you have half here. S here. S is here. Then you have half here. Or let me say s raised power half in general. So and this is also s raised power half. That is true. What is left? Here it is something minus 1, but here we have what? 2 alone, like a term. Let us make it to be 2 term as well. Then you can as well transform this. This is going to give you integral from 0 to infinity s raised by half. Then I can say this is also 3 minus 1. Since 3 minus 1 will give me 2, so which means I've transformed it to what? To 2 term, with the last term as what? Minus 1. Then I'm going to have the last term, which is what? So the last term, which is e raised power minus s raised power half. You see now, if you check this very well, then this is the same thing as integral what? Yeah, this is the same thing as gamma of what? And this is the same thing as gamma 3. You understand now? If you check this one, e raised power minus x, Sn minus 1 give gamma of n. Then if you check this, you will observe that it is the same, just that our s, instead of it to be x here, it is just s raised power half. You understand now? So in that sense, your gamma n here is empty is what? Your n here is what? Is 3. So then you can adequately conclude that this is what? Gamma 3. So if that is gamma 3, don't forget the formula I wrote up. One of the formula in the gamma function, that is when you have your gamma n, it's actually the same thing as n minus 1 factorial. So this implies that your gamma n is going to be what? 3 minus 1 factorial. And 3 minus 1 factorial is going to be 2 factorial, which is equal to 2. So you can see it's not difficult to do. If you want to try it, you can use partial fraction to solve this, but you are going to have this now. So, but I will advise you not to waste your time. In essence, you have the question together, then you are expected to actually apply, what you've learned on gamma function. So that's that. If that is clear, please don't forget to like my channel, subscribe to it, and share with your friends so that they can benefit too. See you in the next SR. Bye.